This problem is 1.33. This is about an adjustable support which can slide up and down through this post, and the coefficient of friction between the post and the hanger is 0.3 here. The load that is given here is 50 times of the weight of the hanger, and the weight of the hanger is right here, W, and we need to figure out this distance x here so that there is no slipping happening. So for this case, if you consider this post here, these are basically circular holes here that you can see. So when this load is applied vertically downwards, because of this load, in this groove right here, the contact will be on the back side on the top one, and the contact will be happening on the front side here at the bottom one. So in terms of contact forces, there will be a force going backwards, and if this point is A, I can call this FAX, and there will be a friction force going upwards, FAY, which is going to be between these two surfaces. Now at this point, your contact in the x direction is going to be this way here, and since the tendency of motion is downwards, so your friction force is going to be upwards here. Now based on these forces, we can start writing the force balance equation. So force balance in the x direction will give us FAX, which is in the minus direction, plus FBX equals to 0. In the y direction, we are going to get FAY plus FBY is equals to this W and 50W put together, so 51W. Now the third equation we can get from here is from the moment balance, and for this purpose we can do the moment balance about point A. So the summation of moment about point A equals to 0. So this will give us, if I am considering moment about this point, first 50W force. This is acting at a distance of x coming from here and another 100 here. So x plus 100. This is clockwise movement, so this is going to be positive. Then this W force, which is sitting at a distance of from the A point 250 plus 100, so 350 there. Now FBX here is going to give us counterclockwise movement, so I'll put it as a negative sign, and this is acting again at a distance of 350 mm. And similarly your FBY is also going to be counterclockwise, which is at a distance of 100 equals to 0. So far we have got one equation here, second one here, and third one here. And in terms of unknowns, we have FAX, FBX, FAY, FBY, and X. So there are total 5 unknowns. So we need 2 more equations, and those 2 equations will come from the friction relationship, which is your FAY is equals to 0.3 times FAX. So this is your fourth equation. Similarly, your FBY is equals to 0.3 FBX. This is your fifth equation. So now if I solve equation 1, 2 and 4, 5, if I use these, substituting the value of FAY here in terms of FAX and here in terms of FBX, and using this relationship, which is FX equals to FBX, we can find the value of FAX equals to FBX to be 85 times W, and using fourth and fifth relationship, we can get FAY equals to FBY equals to 25.5 W. So once we have these two values, we can go ahead and substitute back into equation number 3 and solve for the value of x. And if I substitute everything there, the value of x is 539 millimeters. So this is the minimum required distance so that this hanger is not going to slide.